Hello students, how are you? I hope all of you are good. So in my previous video, I discussed the complete introduction part for the exercise 11.1. So in this video, I am going to solve the problems in exercise 11.1. And the question is, if a line makes angle 90 degree, 135 degree and 45 degree with the x, y and z axis respectively, then find its direction cosines. Here he has given that one of the line makes an angles 90 degree, 135 degree and 45 degree with the x, y and z axis respectively, and we need to find their direction cosines. So as you know that if this is a x-axis, y-axis and z-axis, and which is the origin. So if a line, if a line makes angles alpha with the x-axis, beta with the y-axis, and gamma with the z-axis, then the direction cosines of this line L is cos alpha, cos beta, and cos gamma. So where cos alpha is L, cos beta is M, and cos gamma is N. So in this question, he has given that. He has given that line makes angle 90 degree with the x-axis. It means the value of alpha is 90 degree, and 135 degree with the y-axis. Therefore, beta is equals to 135 degree. And gamma with the z-axis. That is what 45 degree with the z-axis. Therefore, gamma is equals to 45 degree. Therefore, the direction cosines of given line. Therefore, direction cosines of given line is what? L, M, and N. And the value of L is what? Cos alpha, where alpha is 90 degree. So, cos 90 degree. And the value of M is, and the value of M is cos 135 degree. Cos 135 degree, and the value of n is cos 45 degree. So as you know that the value of cos 90 degree is 0, and the value of m cos 135 degree can be done as cos of 180 minus 45 degree. And by the allied angle formula, cos 180 minus theta is minus cos theta, where theta is 45 degree. And the value of cos 45 is 1 by root 2. Hence, the value of m is minus 1 by root 2. And the value of n is cos 45 degree, that is what? 1 by root. So, therefore, direction cosines of given line. Therefore, direction cosines of given line are what? 0, minus 1 by root 2 and plus 1 by root. I hope all of you understood this question. So let's start the next second question. And the second question is, find the direction cosines of a line which makes equal angles with the coordinate axis. So here in this question we need to find the direction cosines of the line which makes equal angles with the coordinate axis, means what? X, y and z axis. X, y and z axis. See here, suppose a line, suppose, so let's say this is a x axis, y axis, z axis and origin. See here, suppose the line L, suppose the line L makes an angle alpha with the x axis, beta with the y axis and gamma with the z axis. So according to this question, he has given that this line makes equal angles, means he has given that alpha equals to beta equals to gamma, and we need to identify the values of L, M and N for this line. See here, we know that one of the relation between direction cosines of a line, that is what? L square plus M square plus N square is equals to 1, where L is equals to cos alpha, it means cos square alpha, and M is equals to cos beta, means cos square beta, plus N is equals to cos gamma, means cos square gamma is equals to 1. But in this question, he has given that alpha equal to beta equals to gamma. So by this given information, this equation can be written as cos square alpha plus cos square alpha, because beta is also equal to alpha, plus cos square alpha, since gamma is also equal to alpha. So now cos square alpha plus cos square alpha plus cos square alpha is equals to 3 cos square alpha, which is equals to 1. and hence cos square alpha is equals to 1 divided by 3. Therefore, the value of cos alpha is equals to plus minus square root of 1 by 3. So, square root of 1 is 1 divided by root 3. And this is the value of L. So, L is nothing but cos alpha. Therefore, the value of L is equals to plus minus 1 by root 3. And the value of M is equals to, value of M is equals to cos beta, but the beta is equals to alpha, therefore m can be rewritten as cos alpha, and we know that the value of cos alpha, that is what, plus minus 1 by root 3. So plus minus 1 divided by root 3, and the value of n is equals to what, cos gamma. So gamma is also equal to alpha, therefore n can be written as cos alpha, and the value of cos alpha is same thing, that is what, plus minus 1 by root 3, that is what, plus minus 1 divided by root 3. Therefore, so we got direction cosines of a line which makes equal angles with the coordinate x's. Direction cosines of given line is what? Value of L plus minus 1 by root 3, and the value of M is also plus minus 1 by root 3, and the value of N is also plus minus 1 by root 3. I hope all of you understood. So one more thing, this question is asked in your KCET examination as well as your PU board examination. So one of the important question. I hope all of you understood. So let's start the next question. The next question is, if a line has the direction ratios minus 18, 12, minus 4, then what are its direction cosines? See here in this question, he has given that the direction ratios of the line, that is minus 18, 12, minus 4. And we need to identify the direction cosines. As you know that direction ratios of a line is denoted by A, B and C. So in this question, he has given that direction ratios of a line, they are nothing but A, B and C. And the value of A is minus 18, value of B is 12 and C is minus 4. And we need to identify the direction cosines. And when direction ratios of a line are known, then direction cosines of line are what? L, M and N. And the value of L is equals to A divided by square root of A square plus B square plus C square. And the value of M is B divided by square root of A square plus B square plus C square. Similarly, the value of N is C divided by square root of A square plus B square plus C square. So he already given the values of A, B and C. So for their L, M, N, we need what? Square root of A square plus B square plus C square value. So what next? We need the value of square root of A square plus B square plus C square, which is equals to square root of. See here, A square means minus 18 square, and minus 18 square is 324, plus 12 square, 12 square means 144, plus minus 4 square, minus 4 square is 16, which is equals to square root of, say 6 plus 4 10, 10 plus 4 14, and then 1 plus 1 2, 2 plus 4 6, 6 plus 2 8, and then 1 plus 3 is 4. So therefore square root of A square plus B square plus C square is equals to square root of 484, and the value of square root of 484 is 22. Therefore, we got the value of required square root of A square plus B square plus C square, which is equals to what? 22. Hence, the required direction cosines of the line L is equals to A divided by 22, where A is minus 18. So hence, L equals to minus 18 divided by 22, which is equals to minus as it is 2 9s are 18, 2 11s are 22. And similarly, the value of M is equals to B divided by, B is what? 12. So 12 divided by 22, which is equals to 2 6 are 12, 2 11 are 22. And the value of N, C divided by, where C is minus 4. So minus 4 divided by 22, which is equals to minus 2 2s are 4, 2 11s are 22. Hence, the required direction cosines of the line. Therefore, the required direction cosines of line is equals to what? Minus 9 by 11 and then 6 by 11 and then minus 2 by 11. I hope all of you understood. So let's start the next question. And the next question is, show that the points 2, 3, 4, minus 1, minus 2, minus 1 and 5, 8, 7 are collinear. Here we need to prove that the given 3 points are collinear. So let's say the first point is A point and second point is a B point and third point is C point. And let the coordinates of the first point is x1, y1, z1 and second point x2, y2, z2 and third point x3, y3 and z3. So here we need to prove these 3 points are collinear. Collinear in the sense we need to prove that these 3 points A, B and C lies on the same line. And we know that condition of collinearity of 3 points, that is what? We need to prove that direction ratio of the line segment AB is proportional to the direction ratio of the line segment BC. Direction ratios of the line segment AB is proportional to direction ratios of the line segment AC. Or direction ratios of the line segment AB is proportional to direction ratios of the line segment BC. Or direction ratios of the line segment BC is proportional to direction ratios of the line segment AC. So you can prove any one condition among these three. Then we say that these 3 points are collinear. So let's say I am going to consider the first case here. I am going to consider the first case here. And the first case is first line segment, that is what? Direction ratios of AB segment. First we need what? Direction ratios of the line segment AB. Direction ratios of line segment AB. So let's say A1, B1 and C1. And as you know that the direction ratios of line segment joining 2 points is what? X2 minus X1, X2 minus X1 and Y2 minus Y1 and Z2 minus Z1. So here direction ratios of the line segment AB, where A is first point, B is second point. So therefore x1, y1, z1 is the coordinates of the point A and x2, y2, z2 is the coordinates of the point B. Therefore, the required direction ratios x2 minus x1 means minus 1, value of x2 is minus 1 minus x1 is 2. Similarly, value of y2 is minus 2 minus value of y1 is 3. And similarly, the value of z2 is 1 minus value of z1 is 4. Therefore, the values of a1 is minus 3 and b1 is minus 5 and c1 is minus 3. So, we got the direction ratios of the line segment AB. And then next thing we need to identify direction ratios of AC. Let's say the direction ratios of AC is A2, B2 and C2. Similarly, here the first point is A and the second point is C. We consider the coordinates of the A point x1, y1, z1 and coordinates of the C point is x3, y3, z3. Therefore, the value of A2 is what? x3 minus x1, x3 minus x1 and B2 is y3 minus y1 and C2 is z3 minus z1. Now see here. Here the value of x3 is 5 minus x1 is 2 and the value of y3 is 8 minus y1 is 3 and value of z3 is 7 minus value of z1 is 4. Therefore, the values of A2, B2, C2, 5 minus 2 is 3 and 8 minus 3 is 5 and 7 minus 4 is 3. So, first set is the direction ratios of the line segment AB and second set is nothing but direction ratios of the line segment AC. Now, we need to check whether the direction ratios of AB are proportional to direction ratios of AC. If they are proportional, then we say that these 3 points are collinear. If not, these 3 points are not collinear. So here, what is the condition of collinearity of 3 points? See here. Now what? Let's check. Let's check condition of collinearity. Collinearity of 3 points. That is what? A1 by A2 equal to B1 by B2 equal to C1 by C2. If A1 by A2 equal to B1 by B2 equal to C1 by C2, then definitely the given 3 points are collinear. So let's what? Let us consider. Now what? Consider A1 by A2. The value of A1 is minus 3. Divide by A2. A2 is 3. So minus 3 by 3 is minus 1. Similarly, consider B1 by B2. And the value of B1 is minus 5. Divide by B2 is plus 5. And minus 5 divided by 5 is minus 1. And consider C1 by C2. Value of C1 is minus 3. Divided by C2 is 3. So minus 3 by 3 is minus 1. So observe here, A1 by A2, B1 by B2, C1 by C2, all are equal to minus 1. Since A1 by A2, B1 by B2 and C1 by C2 are equal to minus 1, it means given points A, B and C. It means given points A, B and C are what? Collinear. Are collinear. I hope all of you understood this question. So let's start the next question. And the next question is, find the direction cosines of the sides of the triangle whose vertices are given by 3, 5, minus 4, minus 1, 1, 2 and minus 5, minus 5, minus 2. See here he has given that vertices of the triangle. So let's say the first vertex is P and the second vertex is Q and the third vertex is R. So we need to identify the direction cosines of the sides of the triangle PQR. So here he has given that the triangle, see here he has given that the vertices of the triangle. So let's say P, Q and R. If P, Q, R are the vertices of the triangle, then definitely sides of sides of triangle PQR should be equal to what? PQ, and what? QR and then what? RP and what? RP. So we need to find the direction cosines of the sides PQ, QR and RP. I hope all of you understood. So this question is also similar to previous one because PQ is a line segment joining 2 points. See here. So to identify the direction cosines of PQ, first we need its direction ratios. So let's say direction ratios of first side. What is what? PQ. Side PQ. And let's say they are A1, B1 and C1. So PQ is a line segment joining 2 points. Therefore, their direction ratios are x2 minus x1, y2 minus y1 and z2 minus z1. In this side, the first point is P and second point is Q. Therefore, let's say the coordinates of the point P is x1, y1, z1 and coordinates of the point Q is x2, y2 and z2 and let's say the coordinates of the point R is x3, y3 and z3. Now see here, for direction ratios of the side PQ, value of A1 is x2 minus x1. Here the value of x2 is minus 1. So minus 1 minus value of x1 is 3. Similarly, value of y2 is 1 minus y1 is 5 and the value of z2 is 2 minus z1 is minus 4, minus into minus plus 4. Therefore, the value of a1 is minus 4, B1 is minus 4 and C1 is 6. These are the direction ratios of the side PQ. But we need what? Direction cosines. But we need what? Direction cosines. See here, when direction ratios of the line is known, then definitely direction cosines. See here, then definitely direction cosines of side PQ should be equal to L, M and N. The value of L is A1 divided by square root of A1 square plus B1 square plus C1 square. And similarly, the value of M is B1 divided by square root of A1 square plus B1 square plus C1 square. And similarly, the value of N is C1 divided by square root of A1 square plus B1 square plus C1 square. So we already know the values of A1, B1, C1. We need value of square root of A1 square plus B1 square plus C1 square. See here. Now the value of what? Square root of ಇಲ್ಲೇ ಮಾಡ್ತು ನೋಡ್ರಿ square root of A1 square plus B1 square plus C1 square is equals to square root of A1 square means minus 4 square, which is equals to 16, plus B1 square is also minus 4 square, which is equals to 16, plus C1 square means 6 square, which is equals to 36. And this value is equals to square root of 16 plus 16, 32. 32 plus 36 is 68. 68. And this can be written as, see here, 4 into 4 ones are 4, remaining 2, so 28, so 4 sevens are 28. Therefore, this can be written as square root of 4 is 2 into root 7. Hence, the value of root A1 square plus B1 square plus C1 square is equal to what? 2 root 7. Therefore, the required direction cosines of the side PQ is A1 means minus 4 divided by 2 root 17. 2 root 17. So now here I can cancel 2 ones are 2 twos. So therefore the value of L is minus 2 divided by root 17. And similarly the value of M, B1. B1 is what? Minus 4 divided by 2 root 17. So here I can cancel 2 ones are 2 twos. Therefore the value of M is minus 2 divided by root 17. And the value of C1. C1 is 6. So 6 divided by 2 root 17. So 2 ones are 2 threes. So which is equals to 3 divided by root 17. Therefore the direction cosines of the side PQ is minus 2 by root 7, minus 2 by root 7 and 3 by root 7. So these are the direction cosines of first side, that is what? PQ. And now we need the direction cosines of second side, that is what? QR. So what is the next step? So in next step we need the direction cosines of the next side QR. So for that first we need the direction ratios of the side QR. So direction ratios of side QR. So let's say the direction ratios of the QR. Let's say direction ratios of the side QR A2, B2 and C2. I hope all of you understanding. So in the side QR, first point is Q. So second point is R. Therefore, the value of A2 is, see here, Q point R point. Value of A2 definitely equal to X3 minus X2. X3 minus X2. And B2 is Y3 minus Y2. And similarly, C2 is Z3 minus Z. So therefore, the value of A2 equals to X3 is minus 5 minus X2 is minus 1 minus into minus plus 1. And B2, Y3 is minus 5 minus Y2 is 1. And Z3 value is minus 2 minus Z2 value is 2. So hence A2 equals to minus 5 plus 1, which is equals to minus 4. And minus 5 minus 1 is minus 6. And C2 minus 2 minus 2 is minus 4. So for the direction cosines, we need what? We need square root of A2 square plus B2 square plus C2 square, which is equals to square root of, which is equal to square root of. So minus 4 square is 16 plus minus 6 square is 36, again minus 4 square is 16, and which is equals to here. This value is similar to this one, 16 plus 16 plus 36, 16 plus 16 plus 36. So therefore this is also equal to what? 2 root 17. This is also equal to what? 2 root 17. 2 root 17. So now required direction cosines. Now what? Required direction cosines of side. What? QR. Direction cosines of side QR. Let's say L, M and N. The value of L is equals to a2 minus 4 divided by square root of a2 square plus b2 square plus c2 square, which is equals to what? 2 root 17. So same 2 ones are 2 twos are, so value of L is minus 2 divided by root 17. And the value of M is minus 6 divided by 2 root 17. So 2 ones are 2 threes are. So therefore M is equals to minus 3 divided by root 17. And the value of N is minus 4 divided by 2 root 17. Same thing, 2 ones are 2 twos are. So therefore N is equals to minus 2 divided by root 17. I hope all of you understood. So these are what? Direction cosines of the second side. So we need direction cosines of the third side, that is what? RP. Now what? Direction cosines of the third side RP. So for that first we need its direction ratio. So therefore direction ratios of third side, that is what? RP. And let's say that its direction ratios are, let's say its direction ratios are A3, B3 and C3. So as you know that here the first point is R and the second point is P, where the coordinates of the point R is x3, y3, z3 and coordinates of the point P is x1, y1, z1. Definitely A3 is equals to x1 minus x3, x1 minus x3, and the value of B3 is y1 minus y3, y1 minus y3, and the value of C3 is z1 minus z1 minus z3. So therefore the value of A3 is equals to x1, value of x1 is 3 minus x3 is minus 5, so minus into minus plus 5, so 3 plus 5 is 8, and the value of y1 is 5 minus y3 is minus 5, minus into minus 5 plus 5, so 5 plus 5 is 10, and the value of z1 is minus 4 minus z3 is minus 2, minus into minus plus 2, so minus 4 plus 2 is minus 2. Hence the direction ratios of the side RP is equals to 8, 10, minus 2. Now to find its direction cosines, first we need the value of square root of, first we need the value of square root of a3 square plus b3 square plus c3 square. So therefore what is the next step? Square root of a3 square plus b3 square plus c3 square, which is equals to square root of a3 square means 8 square, value of 8 square is 64, plus b3 square means 10 square, value of 10 square is 100, plus c3 square means minus 2 square, value of minus 2 square is 4, which is equals to square root of, see here, 100 plus 64 is 164, 164 plus 4 is 168. And now see here, this 168 can be written as 168 can be written as square root of, so 4 into 4 4 is 16 and 4 2 is 8. So therefore square root of 4 into 42 can be done as square root of 4 is 2 into root 42 as it is. Therefore the value of square root of a3 square plus b3 square plus c3 square is equals to 2 root 42. So finally direction cosines of the third side, that is what? RP equals to L, M and N. Therefore the value of L is equals to, therefore the value of L is equals to A3 means 8 divided by root A3 square plus B3 square plus C3 square, that is what? 2 root 42. So here I can cancel 2 ones are 2 fours. So therefore value of L is 4 divided by root 42. Similarly M is 10 divided by 2 root 42. So 2 ones are 2 fives. So 5 divided by root 42. And the value of N is C3 minus 2 divided by 2 root 42. 2 root 42. Same thing, 2 and 2 get cancelled. Value of N is minus 1 divided by root 42. I hope all of you understood. So this is nothing but direction cosines of the sides of the triangle PQR. That is nothing but PQ, QR and RP. These are the direction cosines of the side PQ, and this second set is the direction cosines of the side QR, and last set direction cosines of the third side RP. I hope all of you understood.